Hey everyone, welcome back to the channel. Today we're diving into the fascinating world of malware design. We'll be taking a closer look at the software design of this Cloudsorcerer malware. If you're curious about Cloudsorcerer and their TTPs, be sure to check out our previous video for all the insider info. Let's get started. Today's focus will be on the different components of the malware, how it is loaded into memory, and how the command and control works. As always, sources for everything I will talk about will be in the description below. As of the recording of this video, there are not any publicly available samples of the malware, so we only have the technical write-ups to go off of. The malware we will look at today is from the threat group dubbed Cloudsorcerer. They were discovered in May of 2024 by Kaspersky. The malware is a PE binary written in the C programming language. This is not uncommon, but it does break the trend from the past few years of most malware being written in C#. The malware is split into two components, a backdoor module and a C2 module. The backdoor is responsible for collecting system information, running commands, and running external code. The C2 module is responsible for all the communications between the backdoor and the C2 server. This includes any commands sent to the backdoor and any data sent back to the C2 server. Both modules are stored in a single binary, which we will call the loader. When the loader starts up, it makes a call to the Windows API function get module file name A. This returns the full path of the loader. From this path, the loader determines the name of the process it is running in. The loader is looking for two specific process names. If the process name is MS Paint, the backdoor module is run. Likewise, if the process name is MSI-EXEC, then the C2 module is run. If the process name contains browser or does not match MS Paint or MSI, then the loader tries to inject a shellcode into MS Paint, MSI, or Explorer.exe. The loader does not know which process it is running in because most likely it is injected into a process from malware that is already running on this infected system. The most interesting part of this malware is how the C2 module works. The initial C2 server the malware reaches out to is a GitHub page. A series of standard Windows API functions are called to make a GET request. The malware downloads the entire GitHub HTML page into a memory buffer and begins searching for the bytes CDOY, which should be in the About section. The malware searches each byte in the HTML for the first instance of CDOY. Once this is found, the malware copies all the characters up to the second instance of CDOY into a separate memory buffer. This substring is an encoded bearer token, which is then used to authenticate with a cloud API. To decode the bearer token, a lookup table is used. Each character is converted from a string to a hex value. The hex value is then used as an index into the lookup table. The index in the lookup table is a decoded value of the character. This is also called a substitution table. The first byte of the token tells the malware which cloud provider to use. If the first byte is 1, then Microsoft Graph Cloud is used. If the first byte is 0, then the Yandex Cloud is used. The rest of the bytes are the bearer token. The first byte also tells the malware which virtual function table to use, as each cloud has different functions to communicate with their API. The first step in creating a connection to the command and control server is using this token. Again, a standard set of Windows APIs are used to send data to the cloud. The C2 module also creates two threads to send and receive data from the backdoor module. Windows name pipes are used to send the data. When the C2 module wants to read data or receive commands from the C2 server, it uses a standard set of Windows APIs and the token to read the communication from the cloud. The lookup table is then used to decode the command. Lastly, the C2 server creates a command structure and sends it to the backdoor module using the name pipes. The backdoor module then parses the incoming data to read the command ID. There are 9 actions the backdoor module can do. After the backdoor completes the action, it sends results back to the C2 module to then be sent to the C2 server running in the cloud.